Right, our last section that we worked on, we were solving for trig functions, and most of that was in one, sometimes two steps, where we had to move, do an operation, either adding, subtracting, multiplying, or dividing, to move a value over and then solve for x, and then do the inverse function. So we're doing that same thing in the second part, except this part we're adding another step to solving for that x, or getting theta by itself. And that's going to involve some factoring. So just one thing to remember when you're working with trig functions, sine squared x, and this works for cos, tan, and then the reciprocal functions too, is the same thing as if we would write sine x all squared, which is the same as sine x squared. Okay, so they're interchangeable. If you were to plug in a value there into the x, you would get the exact same solution to that. Okay, so first one, we're solving for when x is in between less than or equal to 0 and, sorry, greater than or equal to 0 and less than 2 pi. So sine squared x minus 4. So the same solution as last time. We're going to move that 4 over. I have a square of a value, so like I said, this is exactly the same as this, so that means all I'm going to do is square root both sides. So that means my sine x is equal to, and this part's important, plus or minus 1/2. So if I want to solve that, I have to figure out which quadrant this is and see if it is from one of my special triangles or my unit circle. So sine, using your cast rule, is positive in, sorry, I'm just forgetting my train of thought here. Sine is positive in quadrant 1. It's positive in quadrant 2. It is negative in quadrant 3, and it's negative in quadrant 4. So I have 4 possible solutions for this. So now I'm going to do my solving and figure out, okay, am I using a 30-60-90 or a 45-45-90? So I'm using the ratio of 1 over 2, so I know that has to be a 30-60-90 triangle. This is 30, 60, and 90. This side is opposite of the 30 degrees is 1, opposite of the 60 is square root 3, and this is 2. So to use sine of opposite over hypotenuse, then that means I'm looking at my 30 degree. And because this is in pi, then I know that this has to be in radians, so pi over 6. So my reference angle is equal to pi over 6. So now I have to figure out what would these be in all of the other quadrants. So in quadrant 1, it is just going to be pi over 6. In quadrant 2, if my reference angle is pi over 6, then I'm doing pi minus pi over 6. So that's 5 pi over 6. In quadrant 3, so that's right here, I'm going to have, it's going to be pi plus that, pi over 6, so that's 7 pi over 6. And then in the last quadrant, in quadrant 4, I'm taking my 2 pi, but I'm pi less than 6 over that. So 2 pi, remember, is the same as 12 pi over 6. So that means that this is 11 pi over 6. Oops, I did that a little close there, so I'll put this answer here. So those are my possible solutions to that question. Okay, so you have to solve it, figure out which quadrants that they work in. This works within my restriction. I don't have an answer that is less than 0, and I don't have an answer that is greater than 2 pi, so I'm good. Okay, example 2, I have cos squared x minus 1. So I'm going to move my x over, square root. So I have cos of x is equal to plus or minus 1. I remember cos is the same as the x coordinate. So I'm looking, if this is an answer of 1, that means that my denominator would have to be a 1 also. So I know that the only spot, so if this, and remember cos is, if it depends how you want to look at it, if you want to say that it's, Kixer, I mean, for Kixer ticks, this is x over r. So to have an r equal to 1, that only works on my unit circle. Or if you're doing adjacent over hypotenuse, hypotenuse is only equal to 1 on that unit circle. So I know then I am doing a unit circle where my x value is 1 is right here at 1, 0, and right here at negative 1, 0. Okay, so then that means that my possible solutions, because I have that restriction, I can use 0, I can use pi, but I can't go back around here to 2 pi because my restriction was, oops, I just wrote that wrong, didn't have the equal to sign, so that's why I can't use 2 pi. Always a good idea just to put a box or a circle around what your final solution is, especially when you're doing a whole lot of solving to get to your answer. So last day we were solving linear equations, and like I said, with this one we're going to be solving equations, but we're going to be solving ones that need to be factored. So our restriction for this is going to be negative 80 is less than or equal to x is less than or equal to 180. So on our, we're doing right to here. Sorry, almost to there. We won't be touching it. So I'm going to fix that. So we're doing everything that's going to this direction, but not touching that, and then everything that is going to this direction and touching that line. So almost touching and not touching. Okay, so in this equation here, it's already been factored for you. Cos x minus 1 and tangent x minus 1 are your factors. That's the same as if we were given an equation like this. Then we would just be saying x equals 1, x equals negative 2. Okay? So that's the same thing. It's been factored, so we just have to do the solve. So we have to go cos of x minus 1 is equal to 0. Tangent of x minus 1 equals 0. Oops, got to give us a second to catch up. So it's as if they factored it for us, and we're finding the solution. Okay. Didn't want my 0. So now I solve each side. So I have cos of x is equal to 1. Tangent of x is equal to 1. So cos of x is equal to 1. That means that my x-coordinate is equal to 1. X-coordinate equal to 1 is on a unit circle. So that's right there. So I know my answer for this one is, and this is in degrees, so it's going to be 0 degrees. And I can't go around there to get to 2 pi or 360 because that is outside of my restrictions. So tangent x is equal to 1. So tangent is equal to opposite over adjacent, or it's the tick, so it's y over x. So I have to think, okay, where would it be then that my y would equal 1 and my x would equal 1? Or my opposite and my adjacent is 1. So that only works on a 45, 45, 90 triangle. So that means that my reference angle for this is equal to, oops, not 90 degrees, but 45 degrees. So tangent, and these are positive, so tangent is positive in quadrant 1, and it's positive in quadrant 3. So I know from quadrant 1, x is going to equal 45 degrees. In this quadrant here, because of my restriction, I can't go, I'll just do this in red so that it's, it's a no. I can't go in this direction, because that would put me at 180 plus a 45, which is above that. So that means that I'm going to actually be going in this direction. So if I'm doing that in this direction, I know I'm going to have a negative reference angle, or a negative angle. So in quadrant 3, I'm doing negative 180, because I'm going in that clockwise rotation. And then my reference angle was 45, so that makes that negative 135 degrees. So that's, I shouldn't have put my box around there yet. Let me redo that one. So this would be negative 135. And then also, altogether my solution would be 0, 45, and negative 135 degrees. So that is my final solution. So you have to watch where you're putting your box around, because this was 45 and negative 135 was only one part of my solution. Okay, next example. I have 2 cos x times cos x plus 1/2. So again, this is in factored form. So I don't need to do any factoring. So I take my first part and I have 2 cos x is equal to 1. I divide by 2. So cos of x is equal to 1/2. Sorry, not 1. My mistake, I was supposed to put it equal to 0. 0 divided by 2 then is just 0. So where is cos x is equal to 0? Again, cos is the equivalent of my x coordinate, so I know I'm using my unit circle. And for it to be equal to 0, where my x is 0 would be right here and right there. So that means that with my restriction, and my restriction was between negative 180 and 180, I think. Yeah. So that means going in this direction, x would equal 90 degrees. And I can't go around to there because that would make it more than 180, so that means I have to go in this direction, which would make it negative 90 degrees. So I've solved for the first factor. For my second factor, I have cos of x plus 1/2 is equal to 0. So cos of x is equal to negative 1/2. So I need to know then which triangle uses adjacent equal to 1 and hypotenuse equal to 2. So that's a 30, 60, 90 triangle. If this is 30 degrees here, 60 degrees, this is square root 3, 1, and 2. So adjacent equal to 1 means I'm using, my reference angle is 60 degrees. This is asking us where is cos negative. So cos is negative in quadrant 2 and in quadrant 3. So in quadrant 2, going in this direction, I'm using 180 minus 60, so that's 120 degrees. In quadrant 3, I can't go, whoops, that's a bad one, all the way around to there because that would put me more than 180, so I throw that one out. But I can go in that negative rotation to put me to there. So that in quadrant 3, it's negative 180 plus my 60 to get me negative 120 degrees. So my total solution for this is going to be x is equal to plus or minus 90 degrees and plus or minus 120 degrees. So you can lump them together like that if they're both, if it's a positive and a negative of a value. So far our new strategy is to factor equations in order to solve them. So these ones were factored for us. Now we're going to make it a little bit harder and do ones where we have to factor them. So we want to factor the following expression, sine squared x minus 3 sine x. So when you look at an equation like that, it looks undoable. But the easiest way to do these, and Jamal, you'll love this, is to substitute. So instead of using signs, we're going to use just letters. Okay, so sine squared x minus 3 sine x. Just 1 second, I'm going to sneeze here. Okay, so like I was saying, we're going to substitute for these. So we're going to pick a value, or not a value, but a variable, and let that equal whatever our trig function is that we're looking at. So, and you shouldn't confuse yourself by using the variable that's there. Choose another variable. So instead of using an x, I'm going to say let q equal sine x. And I just chose q. You could use a, b, you could use c, whatever you want. I'm just using a variable that it's not an x, y, or r, because that's what we use in the circ or ticks, and it's not a s, c, or t, because those could stand for sine, cos, tangent, or cosecant, secant, and cotangent. So I just took a variable that has nothing to do with anything. So that means if q is equal to a sine x, in this one I have a squared. So I have q squared minus, and this sine x I'm substituting in with a q, so I have minus 3q. So now this is just regular factoring. I set this equal to 0 because I'm solving. So if I factor, I'm going to GCF a q to get, whoops, q minus 3. I didn't need an equal sign right there. So I have q times q minus 3 is equal to 0. So now this is factored. I can let my factors equal 0. So q is equal to 0, q minus 3 is equal to 0. So now that I've got it factored, I have each factor equal to 0, then I'm going to substitute back in. So instead of a q, I have sine x is equal to 0, and instead of q minus 3, I have sine x minus 3 is equal to 0. So I solve each one. So we know that once we get to that point, what we would be doing is figuring out, okay, where is sine x equal to 0? For this one, we would have sine x is equal to 3. Well, we don't have a perfect square or a unit circle where it equals 3. For this one, though, all we're going to do is factor. In the next page, we'll get into doing the actual solving. So let's try the next one. Cosecant squared x minus 3 cosecant x minus 28. So I'm going to substitute again. So instead of cosecant of x, I'm going to use a letter to substitute in there. So a variable to substitute in. I'm going to use j this time. I could use q. I decided to use j. So this one means j squared, because it's cosecant squared, minus 3j minus 28 is equal to 0. So this is product and sum. Something times something equals negative 28. Something plus something equals negative 3. So negative 7 and 4 will work. So I have j minus 7 times j plus 4 equals 0. So j minus 7 equals 0, j plus 4 equals 0. And at this point here, instead of saying j minus 7, I could have substituted right in and just said cosecant x minus 7 equals 0. And whoops, cosecant CSC x plus 4 equals 0. So this one will be cosecant of x is equal to 7. This one is cosecant of x is equal to negative 4. So this part is really nothing new. You've done factoring before. This is just factoring with that substitution. And we have done that kind of factoring last year too, when we would have x plus 3 all squared plus 6x plus 2 or something like that. Okay, so this next one. 2 cos squared x plus 7 cos x minus 4. So this time I'm going to say w is equal to cos of x. So this means I have 2w squared plus 7w minus 4. Okay, so if you remember when we have that a variable in front of the first term, in front of our power of 2, we have to try to get rid of it by GCF. And if you do, then you just GCF and then do regular factoring. If you can't, then that's when you're going to use decomp or slide and divide. Remember, slide and divide we figured out is a lot faster than decomp, so that's what I'm going to do here. So I have 2w squared plus 7w minus 4. So the first step in slide and divide is I'm going to take this 2 and multiply it to the back term. So that's the slide. W squared plus 7w minus 8. So now it's just factoring. I have product and sum of negative 8 and 7. So this becomes 8 and negative 1. So w plus 8 and w minus 1. So now I have to take and divide. I move that 2 over, so now I have to divide this by 2 and this by 2, so it's just the value. So this becomes w plus 4. This becomes w minus 1/2. I don't want to have a fraction in that end, so that means that I have to multiply this part of my factor by 2 to get that out of there. So I have w plus 4 and 2w minus 1, because 2 times w is 2w, negative 1/2 times 2 is just a negative 1. So those would be my factors. W plus 4 and 2w minus 1. And those are equal to 0. So now I would substitute back in. I would have cos of x plus 4 equals 0 and 2 cos x minus 1 equals 0. So this is just cos x is equal to negative 4. This would be 2 cos x is equal to 1 divided by 2. So cos of x is equal to 1/2. Okay, so now we're going to actually do some solving. We've practiced with the factoring, so now let's do a few steps of solving. So solve by factoring, our restrictions are it has to be less than or equal to 0, or greater than or equal to 0, and less than 2 pi. So 2 sine squared x minus sine x. So I'm going to pick, again, whatever variable you want, so I'm going to use my w again. So I'm going to let w equal sine of x. So that means I have 2w squared minus w is equal to 0. I factor, I'm going to GCF a w, so I have w times 2w minus 1 equals 0. So now I'm factored as far as I can, so I have to substitute back in. So I have sine of x times 2 Sine x minus 1 equals 0. So sine x is equal to 0. 2 sine x minus 1 is equal to 0. Sine x is equal to 0. That's the same as my y-coordinate. So y is 0 right here and right here. So if it needs to be between 0 and 2 pi, so it's just one complete rotation. So my answer for this would be at 0, and it would be at 180, but it can't be at 2 pi because that doesn't have that equal to sign in it. And this is in pi, so I should be writing this as x is equal to 0 and pi. Okay, so then for my second one, 2 sine x minus 1/2. So 2 sine x is equal to 1, divide by 2, sine x is equal to 1/2. So that's the same as opposite over hypotenuse, or y over r. So a hypotenuse equal to 2 is that 30, 60, 90 triangle. So this is 2, square root 3, and 1. So opposite side is equal to 1, and hypotenuse is equal to 2, means that I'm using this 30 or pi over 6. So x reference is equal to pi over 6. So now I use the cast. This is sine. Sine is positive in quadrant 1 and in quadrant 2. So in quadrant 1, my x is just going to equal pi over 6. In quadrant 2, so that's this one, my reference angle is pi over 2, so it's 180, or pi, I should write it as pi, minus pi over 6, so that's 5 pi over 6. So my final solution is going to be 0, excuse me, pi over 6, 5 pi over 6, and pi. I put these in numerical order. You don't necessarily have to. Okay, next example. I have sine x cos x equals 2 cos x. So I have two variables in this one. So that means for this one, I'm going to let w equals sine of x, and I'll use j. J is equal to cos of x. So I have here wj is equal to 2j. But in order to solve my equation here, I have to have everything over on one side and 0 on the other. So that means I'm going to move my 2j over. So I'm going to have wj minus 2j is equal to 0. So if I solve here, I have GCF of j, so I'm left with w minus 2 is equal to 0. So j is equal to 0, w minus 2 is equal to 0. So I can substitute back in. J is a cos x, so I have cos x is equal to 0, and I have sine x minus 2 is equal to 0. Just going to move that up for you. So cos x is equal to 0. Cos I know is the same as my x coordinate. X is 0 here, and it's 0 here. So I know then for this one, x is equal to, that's up there, so that's going to be pi over 2. Down here is 3 pi over 2. So that one is solved. So for the next one, sine x minus 2 is equal to 0. So I have sine x is equal to 2. So sine is the same as opposite over hypotenuse. So that means that my opposite side is a 2 and my hypotenuse is a 1. Well, you can look at this right off the bat without even doing a whole lot of thinking. This one is saying that my side is larger than my hypotenuse. By definition, for a right triangle, your hypotenuse is your longest side. So right there, you know, you can throw that out. So because the hypotenuse is the longest side, this ratio is not possible. Okay, you could have drawn out your triangles and discovered that yourself, that there is no time when you can have one of your sides larger than your hypotenuse. So that means that this one here doesn't have a solution. So your solution for this particular equation would be pi over 2 and 3 pi over 2. Okay, so this next one, I have a little be careful, and you'll see as we're solving it why that is. So it says tan x sine x plus tan x equals 0. So I'm going to let R, no, I shouldn't use R because that's a ratio, or that's our hypotenuse. Use B. B is equal to tangent x. Well, let's see. Nope, can't use C. Let's use W is equal to sine x. So if I substitute in here, I have B, W plus B is equal to 0. So if I do my factoring, I have B times W plus 1 is equal to 0. So that means B is tangent x, so tangent x is equal to 0, and sine x plus 1 is equal to 0. Okay, so tangent x is equal to 0. So tangent, I know, is the same as, if I'm using Sir Kicks or Ticks, this is y over x. So that means that for this one, my y is going to equal to 0, and my x is 1, but it could be a positive 1 or it could be a negative 1. So if I draw my unit circle, y is equal to 0 here. So here it is at, whoops, wrote that the wrong way, 1, 0. Here it's equal to negative 1, 0. So that means for these 2 points here, my answer is either going to be 0 or it's going to be pi. So that part is solved. So now we're going to do it for the sine x plus 1. So this means that sine of x is equal to negative 1, which is the same as my ratio of y over r. So I have negative 1 over 1. And I know for this, my negative is in the top because sine, or my r, my hypotenuse, can never be negative. So sine is the same as the y coordinate. So I'm looking for a spot where my y is equal to negative 1. So that's down here. This is at the point 0, negative 1. Okay? So that value then would be x is equal to 270 degrees. But from my last page, I can see that my restrictions... Why did I throw that one out? Oh, is equal to 270 degrees. So that fits within the restriction. But if I were to do that... Oh, hang on one second. I think I'm just going to pause. Okay, sorry, I thought I'd made a mistake, but I hadn't. So tangent x is equal to 270. Or sorry, sine of x is equal to 270. So I have to see if this will work with both of my solutions. So 0 and pi will work in here. I can find something where x sine of 0, I have a value for that, and I can do sine of pi, that'll work out. But if I try to substitute this into the tangent, so if I'm saying tangent of x is equal to that negative 270, so, or that 270, so if I'm trying it down here, tangent is equal to, well, I want it to be negative 1, that means using Sir-Kix-Sir-Tix, this has to be negative 1 over 1 to get that answer. So that would mean my y is equal to negative 1 and my x is equal to 1. Well, on this point here, it isn't. That's a 0. X is actually equal to 0 there. So negative 1 over 0 would be an undefined. So that means that this value actually can't work because it doesn't work for both of those. So your solution for this is just going to be x is equal to 0 and x is equal to pi. So you have to do a check when you're working, especially with ones where you have two trig functions in there. You have to check out your solution for both of them. Because I could do sine x is equal to 0. Sine of x equal to 0 is just going to be either here at 0 and pi. That works. Sine of x is equal to pi. Oh, I did that actually for that one. Sine x is equal to pi. That works because that's right here at 180. My sine value is 0. But it doesn't work for going the other way. Substituting my sine solution into my tangent solution. So that's what the be careful is for. You have to do that check. Okay, the next one, 2 sine squared x minus 3 sine x plus 1 is equal to 0. So again, I'm going to say w is equal to sine of x. So I have 2w squared minus 3w plus 1 is equal to 0. So again, I've got that variable, or that that coefficient in front, and I can't GCF it out, so I'm going to use slide and divide. So that becomes, because I'm sliding this over here, w squared minus 3w plus 2 is equal to 0. So this is product and sum. I have w minus 2 and w minus 1 equals 0. So now I divide through by my 2, w minus 1, w minus 1/2. So this becomes w minus 1, multiply through by that 2, so it's 2w minus 1 is equal to 0. So if that's my factor, going back into here, then I have sine x minus 1 times 2 sine x minus 1 equals 0. Sine x minus 1 is equal to 0. 2 sine x minus 1 equals 0. So sine x is equal to 1. So on that one, sine is my y-coordinate. That y-coordinate is equal to a positive 1 right here. So that's at x is equal to pi over 2, or 90 degrees. This one, 2 sine x is equal to 1 divided by 2. Sine x is equal to 1/2. So that means I need to use my ratio where my opposite is equal to 1 and my hypotenuse is equal to 2. So that's this case of a 30, 60, 90. So this is 2, this is 1 here, and square root 3. Opposite is 1, so that means I'm using my 30 degrees, or my reference angle is pi over 6. So this is sine. My answer is positive. So sine is positive right here and right here. So I'm using my pi over 6, and in quadrant 2, it's going to be pi minus, pi over 6. So that's 5 pi over 6. Okay, and I know since these are all sines, I don't need to do a check to see if I can substitute a pi over 6, because obviously if they all started as sines, they all work. So my solution for this is x is equal to pi over 2, pi over 6, and 5 pi over 6. Oops, 6. Okay, in our last section we used the intervals. So instead of using greater than or equal to signs, we used the brackets. And a rounded bracket meant that it wasn't included, and a square bracket means that it is included. So this negative, my intervals between negative 270 and 90, both inclusive, is the same as saying negative 270 less than equal to x less than equal to 90. So this one wants us to solve by factoring it and then state that general solution. So that general solution is when we are going to add that 360n to whatever our solution is. Okay, so cos squared x minus cos x minus 2. So I'm going to let b equal cos x. So I have b squared minus b minus 2 is equal to 0. So this is just product and sum solving, b minus 2 and b plus 1. So I have cos x minus 2 is equal to 0, and cos x plus 1 is equal to 0. So for the first one, cos x is equal to 2. Cos is the same as adjacent over hypotenuse. So 2 over 1. Again, this is a situation where my side is greater than my hypotenuse, so this one has no solution. So I go to the cos x plus 1. So cos x is equal to negative 1. So this means I would have my adjacent side, cos is adjacent over hypotenuse. I thought I wrote it wrong on the other one. So this is a ratio of negative 1 over 1. Okay, so cos x is equal to negative 1. Or if cos x, I could use this adjacent over hypotenuse, because this is the same as saying Kixer. So this is x over r. So I know that that's giving me a unit circle. So cos x is the same, well that's a really bad circle. Cos x is the same as my x value. So my x value is equal to negative 1 right here. So going in a clockwise direction, so if I go this way, this value is going to be 180 degrees. But that is greater than my 90, so that one is out. Going in a in a clockwise direction, where this, because I'm using a negative, would put me here. So that would mean x is equal to negative 180 degrees. And that looks like a really big equal sign. X equals negative 180. Negative 180 fits within that restriction. So then I know I have my solution. So my solution for this is just going to be x is equal to negative 180 degrees. So that's my solution for it. My general solution then is doing that rotation, however many rotations you want, so full rotations at 360, going either in a positive or a negative turn. So my general solution would be x is equal to negative 80 degrees plus 360 degrees times n, and n is an element of integers. So that's the general solution. Okay, last example. Tangent squared theta minus 5 tangent theta plus 4. So I'm going to let v equal tangent to theta. So that means I have v squared minus 5v plus 4 is equal to 0. So this is just product and sum. I have a positive product and a negative sum, so that's going to be v minus 4 and v minus 1 equals 0. So substitute in, I have tangent theta minus 4 is equal to 0, tangent theta minus 1 is equal to 0. So tangent theta is equal to 4. So this doesn't work on any of my special triangles or my unit circle, because I don't have a value of 4. Tangent is y over x, so it doesn't work on the unit circle, and there's no ratios on 30, 60, 90 or 45, 45, 90. So that means that to solve for this, I have to use that inverse. So I have theta is equal to tangent negative 1, tangent inverse of 4. So when you do that on your calculator, you get that tangent, or that theta is equal to 76 degrees. And remember, this particular equation is in degrees, so make sure your calculator is in degrees. So this is the same as my reference angle. So this was a positive 4, so I have to think tangent is positive in quadrant 1, and it's also positive in quadrant 3. So these are my reference angles. So my first angle would be at 76 degrees. That works. And remember, I'm working in between negative 270 degrees and 90 degrees. So 76 degrees works within, it's less than or equal to 90, so I can use that one. If I were to go in a full rotation this way, I would have 180 plus that 76, so that won't work. I can't use that value. It's outside my restrictions. So now I have to try it going in the negative turn. So going in a negative would put me to here. So that would be in quadrant 3. I would have negative 180 plus my 76 degrees to give me negative 104 degrees. So there's two possible solutions for this one. Theta, not Q, is equal to 76 degrees and negative 104 degrees. So now I have to solve for the second one. I'll do this one in purple. So tangent theta minus 1, so tangent of theta is equal to 1. So tangent of theta, that's y over x. So that means that, or opposite over adjacent, x. That would mean that both my y and my x have to have a value of 1. This is the same as 1 over 1, so that only works when I have a 45, 45, 90 triangle, because it's 1, 1, square root 2. So that means for this one, my reference angle is equal to 45 degrees. So if I draw this tangent again, and this is a positive, so it's positive in quadrant 1, positive in quadrant 3. So in here, that 45 degrees would work. That's quadrant 1. Quadrant 3, I can't go in that direction because that would put me more than 90 degrees, but I can go in this direction. So in quadrant 3, it's going to be that negative 180 minus 45, so it equals negative 135 degrees. So my total solution for this would be theta is equal to, where am I? I did a Q again. Theta is equal to 76 degrees, negative 104 degrees, and where am I? 45 degrees, and negative 135 degrees. So my general solution, if you remember from last day, because we're doing a tangent always makes this straight line when you do your all possible solutions. So I don't have to do a 360 because to go from starting from here to get to my next one is a 180 degree turn. To go from here to my next one would be 180. So it works in 180 turns instead of 360 turns. Also for your general solution, you don't need to do it for both of these because if I go 76 minus 180, I'm going to get that 104. So my general solutions would look like this. Theta is equal to 76 degrees plus 180n, and theta would be 45 degrees plus 180n. And again, n is an element of integers, so I can do the negative or I can do the positive. So that's my general solution. That's my complete solution. So that's all there is. When you're doing these, you need to remember to substitute. Then you need, after you've done your solving for x, you have to see if there's any solutions you need to throw out. And that always will work. Where you need to do that check is when you have two different trig ratios in one equation. If they're all sine or all tan or all cos or the reciprocal functions, you don't need to do a check for them because if sine works for one thing, it's going to work for another value if they're in the same equation. So do the questions and you're good to go.